Our solar system is a bustling place. 8 planets along with countless asteroids and comets orbit the sun. But have you ever stopped to think about the star at the center of it all? The sun is much more than just a source of light and heat. It's a giant ball of plasma, a churning sea of charged particles, and it's the reason our solar system exists at all. Without the sun's gravity holding everything in place, our planet would be flung out into the cold emptiness of space. The sun's influence extends far beyond just keeping things in orbit. It's the primary source of energy for almost all life on Earth. Plants use sunlight for photosynthesis, creating the oxygen we breathe and the food we eat. Animals in turn rely on plants or other animals that eat plants for their survival. The sun's energy also drives our weather patterns, creating wind, rain, and even hurricanes. It's responsible for the beautiful auroras that dance across the sky at the poles. The sun truly is the heart of our solar system, and understanding it is key to understanding our place in the universe. When we look up at the night sky, we see countless stars, some brighter than others. It's easy to think of our sun as just another star, but it's actually much closer to home. And while it may seem like just a small dot in the vastness of space, the sun is surprisingly large. In fact, the sun is so large that you could fit over 1 million Earths inside of it. It contains over 99.8% of the total mass in our solar system. That means everything else, all the planets, asteroids, comets, and even the dust, makes up less than 0.2% of the solar system's mass. That's how massive our sun truly is. But here's the surprising part. Despite its size, the sun is considered an average-sized star. There are stars out there much larger and much smaller than our own. Some stars are so large that if they were placed where our sun is, their outer layers would extend beyond the orbit of Mars. Astronomers classify stars based on their size, temperature, and luminosity. Our sun falls into the category of a yellow dwarf star. This might sound underwhelming, but it's actually a very important classification. Yellow dwarf refers to the sun's color and size. It emits light primarily in the yellow part of the spectrum, which is why it often appears yellow to our eyes. However, as we'll see later, the sun's true color is a bit more complex than that. The dwarf part of the name simply means that the sun is a relatively small star compared to giants and supergiants that populate the universe. The most important thing about the sun being a yellow dwarf is that it's currently in the main sequence of its life cycle. This means that it's fusing hydrogen into helium in its core, a process that releases tremendous amounts of energy. This energy is what powers the sun and allows it to shine. Section 4. Why so yellow? You might be surprised to learn that the sun isn't actually yellow. At least, not exactly. In space, the sun appears white. This is because sunlight contains all the colors of the rainbow which combine to create white light. So why does the sun often appear yellow from Earth? The answer lies in our atmosphere. When sunlight enters the Earth's atmosphere, it's scattered by the gases and particles in the air. Blue light is scattered more easily than other colors, which is why the sky appears blue. This scattering effect also removes some of the blue light from the sunlight that reaches our eyes, making the sun appear slightly yellow. At sunrise and sunset, the sun appears even more red or orange. This is because the sunlight has to travel through more of the atmosphere to reach us, and even more blue light is scattered away. The remaining light is dominated by longer wavelengths like red and orange, giving the sun its characteristic warm hues at these times of day. Section 5. The sun's furnace, not your backyard bonfire. It's a common misconception that the sun is a giant ball of fire. After all, it's incredibly hot and bright, and it seems to give off heat and light just like a fire. However, fire is a chemical reaction that requires oxygen, and there's no oxygen in space. The sun's energy comes from a completely different process called nuclear fusion. Deep inside the sun's core, the temperature and pressure are so intense that hydrogen atoms are forced together to form helium atoms. This process releases an incredible amount of energy in the form of light and heat. The sun is constantly converting hydrogen to helium in its core, and this process has been going on for billions of years. It's estimated that the sun has about 5 billion years of fuel left before it runs out of hydrogen. When that happens, it will enter a new phase of its life cycle, eventually expanding into a red giant and engulfing the inner planets, including Earth. But don't worry, we have plenty of time to figure out a plan B before that happens. The sun, despite the fact that it holds us in place, isn't always nice to us. as at times it releases particles called solar radiation, which could disturb electricity and internet, but at the same time would create stunning auroras that will be visible for miles. Still, even though he cannot talk, the sun would ask forgiveness by protecting us from cosmic rays with the heliosphere, aka the sun's magnetic field.